Alright guys, how's it going? So we're going to take a deeper look at our exponent properties. So what I want you guys to do is pause the video before you go to the next slide and make sure you have paper out, something to write with. You're going to be taking notes. I want you to get down the properties that I'm giving you, label them. I want you to also get down some examples for each one. Keep your notes nice, neat, and organized. We're going to be going through, we're going to be doing a couple of example problems where you're going to get to work and check your answer, and then at the end you're going to copy down a bunch of problems and work on them on your own. That'll be homework, and you'll be turning that in tomorrow. Also, at the very end, the last slide, it has a questionnaire. You need to leave your full name and leave me some feedback about the video. So if you have any questions, you can tweet me. The link's down there. YouTube channel's up. I'll also put this on YouTube. Have a good day, guys.
So first we're going to look at the product property. The product property tells us that when we multiply, looking at the operation here, we're going to multiply common bases, we add the exponents. So first we have to look at what the base is. Our base is A. This represents any base. So let's call it out our base. That when the bases are the same. So we're looking at our bases. Now we look at our exponents. Our exponents in this case are going to be m and n. So here's our first exponent, here's our second exponent. This property tells you to add the power. So we're going to have a, the base stays the same, condense it into 1. A times m plus n. That is what the property is. This works this way because let's say we had a to the second power times a to the third power. We know that they tell us to add, so we're going to have a to the second plus the third, and that's going to equal a to the fifth. To look at this way in expanded form, we would have 2 a's for this one, a times a, 3 a's for this one, so times a times a times a. How many is that? 5, so it's going to be a to the fifth power. So next up, we're going to look at the quotient property. Quotient property. Quotient is the answer to a division problem, so we need to have a division problem. So the quotient property is a, representing our base, raised to the m power, divided by, because we're dividing, a to the n, so we still have common bases, the bases are the same, that when you divide, you subtract. So when you multiply for product property, you add. When this one, you subtract, so it's going to be a, base the same, m minus n. So it's the power on top subtracted by the power in the denominator. For example, a to the 3, a to the third power, divided by a to the first power equals a to the 3 minus 1, which equals a squared. Quotient property. So the zero power property is when you raise anything to the 0 power, and what happens is if you raise a base to the 0 power, it will become 1. This is only not the case when a is equal to 0. A cannot be equal to 0. You cannot have something that looks like this, 0 to the 0 power. That will not work. That is not a valid use of this property. So anything, whether it's 100 or it's x, when it's raised to the 0 power, will be 1.
Negative power property.
So the negative power property is a little bit different. It's when you have bases raised to a negative exponent. So this one is raised to the negative m. So what we need to do is we need to turn this into a fraction. So it's going to be a over 1. And what you're going to do is you're going to flip it and change the sign. So what that means is this is going to be the reciprocal of a over 1. So it's going to be 1 over a. Now the power, the exponent comes with the base, so it's going to become m. It is no longer negative. You lose the negative, it becomes positive. So it's a to the m. The other example of this is when you have a fraction already, and this is just kind of compounding what we just worked on, a over b to the negative m. So what you do, flip the whole fraction and make the power positive. So a over b to the negative m power becomes b over a to the m. And remember that anytime you have a variable or any whole number, you can make it a fraction by putting it over 1. So next up we have the power of a quotient property. And remember that a quotient is the answer to a division problem. So when we have, say, a fraction or a numerator-denominator situation with multiple terms, we need to distribute. So what that means is that this exponent here, whatever it is, will be going to the a and the b. It'll be being attached to both of the bases. So what you'll get is a to the m divided by b to the m. If you happen to have negatives or anything, that would also get distributed with it. So next up we have the power of a product property, and this is looking at a product, so a multiplication problem. In this case we have a times b. Remember that if you have two numbers next to each other or a coefficient in any base, they are being multiplied. So a times b to the m. So just like with quotient property, when we multiply with these power of properties, they need to be distributed. So this m is going to be going to both bases. So right now we will have a to the m times b to the m, and that could also be written as am bm. So lastly, let's take a look at the power of a power property. So the power of a power property is when you have a power raised to another power. And what it tells you to do is it tells you to distribute that power, and it'll be a, your original power is m, times n, whatever power you are raising it to. So a to the m times n power, or you could look at it like this, a to the m n power. Now, every time you raise something to a power, you're really getting an example of this, because for example, if we just had a here, which was what we do, it is a to the 1. And when you're raising a to a power, it looks like this, a to the m. So it's going to be a times 1 times m, which we know is just a to the m. So the big idea here is that when you raise powers to a power, you multiply. We're going to look at product property examples. Remember, the product property tells you when you multiply, you add. So we're going to look at this one. We have the base of 2, exponent 5 and 3. So we will add those up. We will get 2 to the power of 8. So now we have x to the 7th times x to the 6th. We add the powers, so we're going to get x to the 13th.
Oh, yeah.
Can also have examples where we have negative exponents. You add the same way. So we have a to the 4th times a to the negative 2nd. We add the powers. 4 plus negative 2 is positive 2. You will also run into examples where you have coefficients. Remember, coefficients are numbers in front of variables. So when you have coefficients, you will multiply them together. So we will get 3 times 4, which is 12. X and x is your base, so that will stay the same. We're going to have x, and then you add your exponents. 2 plus 6 is 8. So the answer for 3x squared times 4x to the 6th is 12x to the 8th power. So here's a couple for you to try. Please pause the video, work them out, write the answers, and then I will give you the explanation in a second. So hopefully you finished up. We're going to apply the product property. We're looking for common bases, and we're going to add the power. So 7 is our base. Our exponent is going to be 10. This one we have a to the 10. We have to multiply the coefficients. You get negative 6, base of x. Power is 2 and 4. We add those up. We get 6. So we get negative 6 times x to the 6. Remember that this is multiplication going on in there. Last one. We don't have a coefficient here, but we know that anytime you don't have one, that's just 1. So 1 times negative 2 is negative 2. Our base is x. Then we need to add our exponents. Now this is 3, but what is this one? Right, it's 1. Anytime you don't see the power, it is 1, so 3 plus 1 is 4. Those are your answers. Hopefully you got those right. So next up, we're going to be working with some quotient property examples. Remember, the quotient property tells you to keep the bases the same, and when you divide, you subtract. So if we look at the first one, our base is going to stay 3. Our exponents are 6 and 2, so if we would write it out the long way, we would do 6 minus 2, and when we reduce it, it would be 3 to the 4th. And if you were asked to evaluate this to get a final answer, you would do 3 to the 4th, which we know is 81. On the next one, we have x is our base. We know that this is a 1 on the denominator, even if it didn't show it. 4 minus 1 is 3. On the next one, you got to look at the coefficients. Divide those first. What's 4 divided by 2? it is 2. M stays our base. 7 minus 3 is 4. So there we go. Let's do a couple more. So here we have a couple more quotient property examples. Same deal though, we're going to look at the quotients, or the coefficients, sorry. Negative 100 divided by 25 is 4. X cubed divided by x squared, we subtract, we get x to the first, or just 4x. Next one, we got 6 divided by 12. Now we know that that's going to leave us as a fraction, so I would just write it that way. Keep your division bar. You have 1 over 2. Then we work with our a's. We have a to the fourth divided by a to the second. You get a to the second. Now, 1 next to an a to the second looks weird, right? So let's clean that up. It's just going to be a squared over 2. This next one, we have 2 negative coefficients, and you know that a negative divided by a negative is positive, so it's going to come out positive. Now, with this one, 13 divided by 17 is not going to give us anything nice, so let's just leave it as what it is. 13 divided by 17, a cubed divided by a. Subtract, get a squared. B to the 7th over b squared is b to the 5th. So your final answer is 13 times a squared times b to the 5th power divided by 17. So for the zero power property, let's look at a couple of examples. Zero property tells you that as long as your base is not 0, when you raise a base to the power of 0, it becomes 1. So pretty simple. It's x to 0, it's going to be 1. Got a 7 to the 0 power, it's going to equal 1. Got 4x to the 0. Well, let's take a look at that one. So we're going to leave the 4, and x times 0 is 1. So 4 times 1 is 4. So x to 0 became 1, that became 4. This one's really self-explanatory. Anything that you raise to the 0 power will become 1. When you're working with negatives, you're going to want to take a look at how the sign is located, as far as parentheses and whatnot, because just like this stays negative 9, this will stay negative 1. If we have a negative inside parentheses, that will give you a positive 1. So guys, the next set of properties we're looking at are the power of a power property. So it's power of a product, power of a quotient, and power of a power. These are a little bit different, but they're all really related. So if we're looking at it, you know, right here we have a product, right? This is being multiplied. So that's how you know you're using the power of a product. That's what we're using right now. Let me write that, power of a product. So what you do is you take the exponent and you're kind of distributing it. So it's going to go to each of these. You're going to multiply. So this is a to the 1, right, and b to the 1. So what you're going to do is you're going to go a to the n times b to the n. The other way to think about it, down here, because you're not always going to get that multiplication sign. You know that when two terms are next to each other, they are multiplying. So like if it was 3x or something, you're going to get a to the n, b to the n. So let's look at a couple of specific examples. So let's look at this one. If we got a times b, or ab to the 3rd power, we got to distribute that exponent, so you're going to get a cubed, b cubed. Simple enough, right? So here's another example of 2 bases, 2 and x. You're going to raise them both to the 4th power, so you're going to have 2 to the 4th, x to the 4th. Now we're not done because we need to simplify. This 2 to the 4th can be turned into a number that's 2 times itself 4 times. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times x to the 4th power is your final answer. This also can be happening with negative exponents. So same deal, you have 3 bases, 1, 2, 3, and you distribute that power to everything. You're going to get negative 3 to the negative 2nd power, a to the negative 2nd power, b to the negative 2nd power. Now that's ugly, that's messy, you got negative exponents, that's something you never want. So let's finish this out. So we know that anything with a negative exponent needs to get flipped. So if it's in the numerator, it goes to the denominator. If it's in the denominator, it goes to the numerator. So let's first put this over 1. And now we know that let's mark everything we're going to move. So this is going to move, this is going to move, this is going to move. They're all negative exponents. So we're going to get 1 over, alright, because everything's gone. We're going to move that negative 3 first. It's going to be negative 3 squared, a to the second power, b to the second power. Simplify here because that needs to be a number. We got 1 over, sorry, negative 9, a squared, b squared. So again, simple properties can be used to solve multi-step problems. Again, power of a quotient property. This is the one where we need to distribute the property to every term in the numerator and every term in the denominator. So we do that like this. We get a to the m over b to the m. Let's do this with a couple examples. So we're going to have, let's say 3 over x, and it's going to all be to the third power. So you know that you have 2 bases, and this exponent needs to get to both of them. So we're going to have 3 cubed over x cubed, and you're going to end up with 27 divided by x cubed. Let's do one more. If you had an example such as 3x over y all to the 4th power, 3 bases, exponent goes to all of them, 3 to the 4th times x to the 4th over y to the 4th, reduce that, or sorry, simplify that, 3 to the 4th is going to be 81, x to the 4th over y to the 4th. So next up we have the power of a power property. This property states that when you have a base raised to a power raised to another power, you need to multiply. Make sure you take note of that. So when you raise powers to a power, you end up multiplying them. So what this ends up being is a to the m times n. We're going to multiply that. So let's take a look at what that could look like. In action, we have x to the 2nd power raised to the 3rd power. So let's rewrite it once just to see how it goes. We're going to have x squared times 3. That's all one exponent. Multiply 2 times 3, x to the 6th. There we go. Let's look at another one. So if we had 3 to the 2nd power raised to the negative 1 power. Now we got to do this again. So we're going to do 2 times negative 1. That is negative 2. So we're going to get 3 to the negative 2nd. We're not done yet. We need to flip it. Switch the signs. We get 1 over 3 squared, which we know is 1 over 9. So this right here turns into 1/9. Look quite different, doesn't it? So let's take a look at one more example. We could have, let's combine the power of a product property with the power of a power and the power of a quotient property with this. So power of a product, so if we had 3x squared y cubed all to the 2nd power. So what we have is we have 3 different bases. That means we have 3 different exponents. We're going to multiply each exponent by this 2. So first, let's look at the 3. The power to this 3 is 1. What's 1 times 2? It's 2. So it's going to be 3 squared. X, we look at the exponent, it's 2 times 2. So it's going to be x to the 4th. Y is 3. 3 times 2 is 6. Simplify that 3, so you're going to get 9, x to the 4th, y to the 6th. So again, just multiply whatever power is on the outside to every power on the inside. Let's look at a power of a quotient property using this. So power of a quotient, we could have x squared over 3y raised to the 3rd power. Let's do the x first. So 2 times 3 is x to the 6th, 3 to the 3rd, y to the 3rd. So it's, I'm sorry, those aren't zeros, that's circled. That's a 1, that's a 1. We need 3 to the cubed, y cubed. Simplify that 3, you get 27 y cubed. That's your power of a power property. It can be used with any of the other properties as well. So last we have the negative power property. The negative power property tells you that when you have a negative exponent that is bad. We do not want to end a problem with negative exponents, so you need to get rid of it. So the conversion is to follow the pattern. So 2 to the negative 2. We need to convert 2 to a fraction. Now remember, when it's a negative, you're going to flip it and make sure the exponent stays attached. So I'm going to use a different color here because it's going to get a little messy here, but we're going to do a 1 over 2 squared. And then that's where you evaluate. So we're going to evaluate. We're going to go 1 over 4. Over here we got a fraction, a over 3 raised to the negative 3 power. We're looking at number 2. So what we're going to do is we're going to flip the fraction first. So 3 over a to the third. Now, if I was just asking you to remove the negative exponents, you'd finish there. However, now that you know the power of a quotient property, what you can do is you can, what we call distribute this 3, the exponent, so then you're going to have 3 cubed over a cubed, and you're not done until everything's evaluated and simplified, so you have 27 over a cubed as your final answer. So we're looking at our final answers. Then our last one, we have x to the negative 7, same deal, put it over 1, flip it, 1 over x to the 7. Negative exponent property, the negative power property doesn't really get more confusing than that, much more confusing than that, but we will do a couple more examples. So let's take a look at this one. You'll notice that we have the negative exponent in the denominator, so you do the same thing, but we're not going to flip the whole thing, we're just going to flip the x, so you got to bring it up. So you're going to have 2, bring the x up into the numerator, and turn that exponent positive. You're done there. That's all you got to do. It's technically over 1, but we know that anything over 1 can just be rewritten as 2 over x squared. Now this bottom one is a beast, right? On these, I like working inside out. So what I would do is I would handle this x first. Now same deal, we're going to bring it up. So let's do that. We're going to get x times x squared, y squared, and that's all over 1 over the negative 2. Now, if we're looking here, what you could do is you could apply the quotient property and do x to the first minus negative 2 to get x to the third, and then you'll know that that is x to the third up here, but that can be confusing. So I'm going to erase this real quick. So what you got to do now is you need to get rid of the negative exponent. So we're going to apply the negative exponent property and flip it. Or actually, sorry, before we do that, let's combine these x's. So we're going to x cubed, y squared, all to the negative 2 power. It's still technically over 1, but we're past that now. So now let's flip it. So we're going to get 1 over x cubed, y squared, all squared. And then if we really wanted to finish this out, we would distribute the 2, but we're not going to do that right now. So that's basically it for negative exponent property.
Okay guys, so what we need to do is we need to go to the bit.ly to find your homework, your practice. It's in the algebra folder, algebra assignments, lessons, and videos. Go to week 10, that's exponents. There's like 4 or 5 sheets in there. I labeled them level 1, 2, 3. I recommend that if you are struggling a little bit or you want some simple practice, start on level 1, but I want you to go in and copy down 8 problems from each sheet. If you have access to a printer, either after school or at home or something, feel free to print these out and work on them, but we will be checking this tomorrow, so get your homework done.